Welcome everybody to the second talk today. It's about find the happiness in your log. I think it's something about Logstash. And it's brought to us by Jordan Sissel. Have fun.
All right. Long time no see, everyone. Hello. So what Leonard mentioned is that we wanted to have some kind of introductory talk to kind of set like a base level of knowledge in terms of what we were talking about with log management, teasing a bit how our tools can help you solve those problems. And I'm going to introduce Logstash, some other tools, and then we're going to talk about use cases and end with hopefully some live demonstrations that will show you the kinds of power you can get through using tools like this. Before I want to get started, this talk is going to be basically 3 parts. One talking about the open source aspects of it, the next section talking about the technology behind this log management solution, and then thirdly talking about different use cases, and again providing some live demos. It wouldn't be proper open source without having an open source license behind it, and so it is Apache 2 licensed, which hopefully allows your company to use it. We're an open and friendly community. I mentioned this before, but I will say it again, is that the word open to me means that you're inviting, that you accept people of all backgrounds and all angles of approach. And so we tend not to, for example, reject patches. We'll work very hard with the people who are submitting these patches to try and get them integrated. I don't put any particular value, I don't put different values on patches versus bug reports versus people helping out in the community. I think the open source projects are always much more than just the people who are contributing code. It's the people who are evangelizing, who are telling their friends and their coworkers, who are doing presentations like this to say that they like the project. They're trying to get new people involved. And what do I say about this? I've been doing open source for probably 10 years now, and the least happy I will be about a given project is if I approach a project with excitement, but I'm having trouble, and I ask their community, I feel I'm doing something wrong, please help, and they kick you out. They show you the door, right? Or if you submit a patch and they say, your patch is completely wrong, I reject you. Right? Usually, that leaves you with a sour taste. It doesn't make you feel good about the things that you're trying to be involved in. And so whenever someone says, I have a dumb question, can I ask it? There is no such thing as a dumb question. And so the best way I can summarize that is that if you are trying Logstash out, especially for the first time, and you're having trouble, it is a bug in the project. It is not your fault. It's a bug in the documentation, or it's a bug in the software itself. And then
one quick thing, just for that sentence. I love your code. Really.
Thank you. And sometimes it's hard. Open source to me, especially with operations people, you'll be on call and you're having a really bad day and you really don't know what the heartbleed bug in SSL is. But everyone's telling you, you have to upgrade, you have to upgrade. But you would happily upgrade if only you understood it. But no one is willing to stand around and say, this is how it's impacting your business, this is why it needs to help you. Everyone is just screaming about how you need to upgrade it. Right? And I think that's a bad experience. So let's talk about the technology. I'm going to talk about 3 projects that all come together to become what we call ELK. It's 3 projects: Elasticsearch, Logstash, and Kibana. Graylog 2 also uses Elasticsearch. I'm sure Leonard will touch on that as well. But the first project we'll talk about is Logstash. Logstash is for processing and transporting your data. So getting your data in wherever your data is, whether that's on your network switches, whether it's on servers, your applications, mobile devices, if it's through communication channels like ticketing systems or IRC or Jabber. Any of those things, they generate data that has a timestamp on it, and that in Logstash is an event, or it's in a log. And so it's 2 parts. One is transportation and one is processing. We have a plugin model in Logstash that allows you to take data from any source, do some modifications to it. I'll talk about some of the modifications you can do, and then output it anywhere. This is powerful because now if you have an input that takes data, for example, from syslog sources, and you want to have that email you, for example, and let's say that there was no email output in Logstash, you would not have to write a piece of glue that takes syslog and sends it to email. You can just do the glue that sends it to email. Now, there happens to be an output for email already, so you won't have to write that. But the idea of separating your components from where data is coming from, how you're processing it, and how you're outputting it, that's really the fundamental feature of Logstash, is that it helps you glue things together. By way of oh, I forgot to also mention that there's about 50-ish. What is going on? All right, cool. There's supposed to be like a thing in the background. I don't know if you can see it, but that's okay. There's about 40-something different inputs. This could be from, you could just barely see it, right? It's very bright on my screen. There's about 40 different inputs. Inputs are where things come from. This could be files. This could be network sources. This could be databases. This could be communication channels. It could be ticketing systems. It can be email. Filters are where events and logs go to get processed. This is where you could make a decision to, for example, drop a piece of data. You could do an external lookup like DNS. Or if you have an IP address, you could look up with a GeoIP database, you could look up where in the world that IP address is. And actually, I'll show a demo of that at the end of this talk. What else can you do? Logs are in a very unstructured format. They're not friendly for especially non-experts to use. There are filters in Logstash to help you process these weird and strange log formats so that other people can ask questions of the data. And then finally, you're going to want your data to go somewhere. It could go to a database, it could go to a file system, it could go to another communications channel like IRC or your operations HIP chat or Jabber room. It could go to a metric system like Graphite or Ganglia. So here's an example. I haven't heard the word lamp thrown around in a while. It's been probably 5 or 10 years since I've heard it. But we'll use it as an example where you have some kind of load balancer on your, what's the word here? Your business is on the left. The things you're doing with the logs are in the middle and on the right. On the left, you'll have your load balancer. You'll have Apache serving up your application. You'll have MySQL behind that. You'll have PHP actually powering your application. And then various devices on your network that are emitting syslog, what they call syslog. Syslog. And then in the middle, you want to take all of these weird log formats and from different protocols and different ways of representing themselves. They all have different time formats, so you want to normalize that. There's a filter for doing that. You want to parse out things like Apache might log how long a given request took. MySQL could have how long a given database request took. And that your application might have how long it took to render the page. All of that information is really useful, but if it's in the format that it usually shows up on disk, no one's going to be able to make use of it. And finally, you'll want errors like PHP. People write bad code. I write bad code all the time. Sometimes it crashes. You want to find out why it crashed so that you can fix it. Or if it's crashing a lot, you want to find the most common crash and fix that first. And then the last portion is where you're outputting. So we started with inputs, where your data is coming from. We're massaging it, and we're modifying the data so that we can ask questions of it. And now we're outputting it somewhere. Maybe you want to be paged anytime an exception happens in your application, or when the kernel logs that there's a disk failure. Or you want to store it in a storage system like Elasticsearch so that you can search across all of your data. Or maybe you want to get graphs on your data. You want to say, show me the average latency across all of my application servers for the last week. Graphite can help you with that. I think there's a Graphite talk after this. Is that right? Excellent. If you don't know what Graphite is, it is an excellent project. And then finally, maybe you have an operational communications channel where your ops team is maybe possibly remote, or you're talking with your data center technicians, and you want some of that log stream to show up in your communications channel. IRC is good for that. There's also Jabber support. There's HIP chat. Lots of different communication channels. So some example inputs. Is it showing up? OK, it doesn't show up here. So we have files. Files are the most obvious, right? That's usually what you run grep on. What? All right, it's going without me. Computers. All right, I'm just going to let this run its course. It seems to be on autopilot. Can we go back? All right, graphite for metrics, files for where logs typically are. Email is good. You might have cron jobs going to email. There's an input that will read it from IMAP. Please don't go to the next slide. Ah, good, OK. So there's an email input that will read from IMAP. So if you have your cron jobs, for example, spitting out things no one reads to an email address no one ever collects, right? I do that. How many of you have cron jobs that will, every 12 hours, restart a service? No, yes, you can admit to it. It's OK. And you always use the T word. I don't know if it starts with a T in your particular language, but temporary. This is a temporary fix. And there's a comment in the cron job that says, this is a temporary fix. You look at the modification date, and it was 3 years ago. SNMP is another good source of data. A lot of network gear will output syslog, but it'll also output metrics over SNMP. How many packets have gone over a given switch port? You can have it do SNMP traps, so you can have it send a signal out whenever something happens. There's inputs for that in Logstash. Again, syslog. RabbitMQ is another one that we support. It's a messaging technology. If you don't know what it is, it's not important that you know what it is, but it's a message routing system. And then lower level, there's TCP inputs, there's UDP inputs, and lastly, and this is a sample. There's over 40 inputs now. Twitter is a good example. Twitter is great especially for ops. If you have a public-facing company and you want to know when people are very upset with you having an outage, but your ops team doesn't know about it yet. Has that happened? Right? Twitter catches on fire, then your every 10 minutes Nagios checks will run, and then 9 minutes after it's failed, you find out it's failed. Right? So you can use lots of different data sources to figure out what's going on with your systems. OK, so filtering. Every log format is almost always going to have a different timestamp format. So not only do you have weird different structures, but you'll have different timestamp formats, and hopefully some of them are standard, some of them are not. We mentioned, Leonard and I both kind of make fun of MySQL's logs, for example, because they're weird. Apache's log format is weird. There are filters that come with Logstash to help you sort of normalize that. So you can take 30 different log sources in different formats and say, well, let's plot them on the same visual, the same interface, and say, well, this database query failed because a disk failed. Those type of things. GeoIP is an interesting one. GeoIP will let you take an IP address and get a location on the Earth. Fingerprinting is great for anonymizing your data. If you are not, for example, permitted to store IP addresses in your permanent log storage, you could hash them, and that way you can still group by the IP address, for example, when you're searching, but you don't know the actual data that went into it. Lots of log formats come in multi-line formats. Has anyone seen a Java stack trace before? Hundreds of lines long, right? As a human, you see a giant stack trace and you say, that is one log, that is one event, that is one thing that failed. But a lot of log management systems are only programmed to say, well, that line is one event, so your 100-line stack trace just became 100 events. And that's not very good. So Logstash comes with a filter to merge all of that together into one stack trace, into one event, so that you can then say, show me the most common exception. And then maybe the second line is the line of code that caused the exception, so that you can start correlating on those kinds of things. The key value filter I mentioned especially because a lot of log formats, if they are structured, they tend to use this kind of semi-structured, loosely structured format where you have like a key equals value, and then that's repeated across. If you've ever managed postfix mail servers, for example, you'll see that they had this kind of key value pair. And the last one is a user agent filter. Again, these are only examples. There's about 50 different filters. These are for the large part, the most useful. User agent filter will take a user agent string from your browser, and these are things that you might have to write code to do, but there's filters that come with Logstash to help you solve all of that. And it takes the user agent string and breaks it and figures out the operating system that it's running. It figures out the browser version that's running. The last filter I will mention is called grok. Grok is kind of like a regular expressions on steroids. Regular expressions are not pleasant to write. And if you write a really good one today, you will not be able to read it tomorrow. Do you agree? For those of you who do, you're shaking your head. Regular expressions. They seem like such a great solution until you try and maintain the thing that you wrote, and then you can't. And so Grok builds on that. Grok lets you write a regular expression once, and you can reuse it all over the place. So if you wrote a regular expression to match a number, you would just call it number and then use it as like you would use a programming library. You're just calling functions. In Grok, you can say match a number and call it this field. Match an IP address and call it this field. Match this particular kind of date, or match this particular URL pattern. And then I think that's about it on filters. Let's talk about outputs. Lots of different outputs. In general, there's different kinds of categories of outputs. There's communication channels. There's storage. What? Oh, I'm so bad at making slides. Storage, there's archival, S3, there's alerting, there's email also if you wish to be emailed on a specific event. Do you use PagerDuty? Yes. Very cool product. There's a PagerDuty output. So if you know there's a specific exception or specific message that you wish to be paged upon, this is a good way to do it. So that's Logstash. Logstash, summarizing, gives you a great way to transport and process your data. So we're going to talk about Elasticsearch and then find the last piece in this puzzle, which is Kibana. Elasticsearch is a near real-time search and analytics platform. You can think of it as a database. You throw data into it, you can query it. We say near real time because it's usually within a second of writing that data is searchable. And I'll show demos of this, how quick it is, pretty shortly. But the key features I will highlight is that you can do search. So you can say, find me logs matching some query, or find me all of the events that match some error over the past 10 days. These are queries you can do very easily with Elasticsearch, things that would fall over very, very quickly with things like grep. And the analysis side is that you're not, a lot of times you're not looking at just the raw records. I think looking at a wall of text is not a very interesting way to debug problems. Usually you want to summarize the data to find where an anomaly is, and then you'll zoom in and try and figure out, well, what exactly went wrong. The other feature of this system is that it's scalable. You can run one Elasticsearch server, 2, 5, 10, 100, and it all forms together to become one cluster. So as your log storage and log analysis needs go, it can grow with you. What else can I tell you about Elasticsearch? It's not specific to the logging use case. It just happens to be very good at doing log-related things. Its main interface is over HTTP. We maintain a lot of different libraries for accessing it. So if you, for example, want to send all of your log data into Elasticsearch and then use Nagios to say how many, if an error occurs more than 5 times in the last 10 minutes, you can ask that kind of question and then alert on it. The last piece in this puzzle before I get to demos is called Kibana. Kibana is the visualization aspect of it. It's the exploration aspect of it. Exploration, to me, is the most important feature of it. What I mean by exploration is that you're not writing complex queries or syntaxes to ask a computer to give you a dashboard like this. You're more taking a stroll through your data. You're walking around, you're exploring the visuals, you're trying to figure out what, for example, what does this spike mean, right? What does this spike mean? The time range, you can't really see the time ranges. I'll use a bigger font in the demo. But you can see there's 2 spikes. If you accept my proposal that both of these graphs use the same time scan, there's a spike here that doesn't show up here, and there's a spike here that doesn't show up there, right? Those are weird anomalies. The power here is that you don't need to be an expert to identify anomalies. You don't even have to know. I haven't told you what this is graphing yet, but you can see there's a spike, right? And that your human curiosity will say, like, let's zoom in on that. So we'll be demoing that shortly. OK, so I have 25 minutes. Excellent. Is that right? 25? More than that. More? OK, I'm just mentally planning what kind of demos we can do. So we'll talk use cases, and then we'll slide right into actual usage. of the visual exploration part. The story I can tell you here is that a few jobs ago, we had an operations team, we had a development team, and a tech support team that interfaced primarily with customers. And over hundreds of, thank you very much, over thousands of servers, it was difficult for the tech support team to answer questions for users because a user would maybe having an email problem. This particular company was serving email for customers. A customer would have an email problem. Now the tech support team, to help diagnose what's going on, they have to log in to the correct server and look at the correct log file to find out what's going on. And so in order to help the ops team not become keyboards for the technical support staff, the ops team wrote scripts. And those scripts would SSH into a server, run grep, and then do that across 1,000 servers. And that took 20 minutes. And so the efficiency of the tech support team was diminished because in order to answer a question, they had to run a script and wait. And so what happens is you end up either they're going to sit there for 20 minutes and do absolutely nothing, or they're going to try and entertain themselves by either solving additional customer support questions or reading the internet or Facebook. And they've context switched away from the problem they're solving. So because the tooling is bad and it's making them wait, now we have less efficiency. And so when we deployed Logstash, we took the 15 or 20 minute time period to answer questions about the logs. Why doesn't my email work? That's a very simple question that the tech support team is capable of answering given the right access. And you replace that shell script that is essentially logging into servers and running grep. You replace that with something like Logstash, and now your answers come back within seconds or less than that. And so now the tech support team can answer questions much more quickly, customers are happier, everybody wins. So the next use case is to graphing everything. There's going to be a lot of data in your logs that looks like a metric. And if you remember what our definition of a log is that it's a time and some data. Well, a metric is a number that was recorded at a given time. And so in my view, metrics are essentially logs. And we'll show this in an example very shortly. But the idea is that if you have numeric data in your business, you're going to want to graph that. And through those graphs, you'll identify anomalies like this spike. And you'll want to zoom in and figure out exactly what caused that. And so you'll look at the metrics to find the anomaly and zoom in on exactly that time frame. And then you can look at the wall of text, essentially, after you've zoomed in into the very small time frame. Another use case is exploration by non-technical users. In the first use case, I talked about technical support helping customers. Technical support tends to be a technical group of folks. They may not be as technical as your development, your operations team, but they still need to have some kind of technical expertise. But folks like your CEO or the project manager or the marketing research team, they're not going to know what SSH is. And you shouldn't require them to know how to use grep. Exploration by non-technical users is a very powerful thing because there's a lot of questions you can ask of your log data that, if presented in an explorable way, non-technical users can simply just, what's the phrase? I say go to town on the logs. You can just set them loose and they'll go explore, and then your team can focus on the things that your team is good at versus answering questions for the non-technical users. So last one before we get into demos. Has anyone seen this? Latency's looking good. It's great. And oh, it's not so good. What is that? That's bad, right? There's no numbers, but again, non-experts can see that something happened. And if you know that you want latency to be low, that the left side of the graph is good, the right side of the graph is not good, and then something in here happened. And this is why it's really cool to have your metric data in the same system as your general log data. So you can look at and figure out that there was, whoa, flames everywhere. I love technology. You can identify that, we should search here, right? With grep, it's difficult to search in a window like that. You might end up getting data across multiple files, across multiple servers. Oops. All right, we'll wait for that to draw again. But does that make sense, right? You have one system that has the metric data for what is the health of the system, and as well as the same data that will tell you why a system is behaving the way it is. All right, so I want to do one thing before I get into system logs. We're going to go way out. We're going to go into, again, this is time and data, movie releases, right? Movies are released in certain countries on certain times. Right? So we're going to take, let me mirror my display really quick. Okay. So do all of you know what IMDb is? Internet Movie Database. They release the data set that powers the website. And you can do data mining on it if you wish. This particular data set is, wow, you can't read that very well. Let's try. This is Kibana, by the way. Every demo from here on out will be Kibana. Let me just do a time check. Is this going to 10:30 or 10:45? 45? Excellent. All right, plenty of time. Let's do late. Is that easier? Oh, much better. Okay, so at the very top, you can see it's 114 years ago to a few seconds ago, and we have this massive, massive time span of data. Again, looking at just the data yourself, if you're looking at lines of text that say a movie was released, you would never see the shape. Right? And there's two shapes to me that pop out, right? There's this thing that we're releasing more and more things exponentially over time, and there was this, like movies are cool now, so we can start releasing things, and then it flattens out. But it's over countries. So let's look at, and I'll explain some of this in a bit, but I want to show a demo of, let's do it by country. So we have, again, this is exploration. I didn't type a fancy query language in. I'm just interacting with the web interface. This, again, is important because non-technical users are at least fairly comfortable poking around on a website. Right, so I asked it for the top 5 countries for this movie date. Top 5 with respect to occurrences over this 100-year span. And you see that the overwhelming majority is USA and UK releases, followed by Spain, Germany, and Japan. One interesting thing about that while I was looking through this data is that if you look at, what was I going to say? Let's do some Doctor Who fans in here. Doctor Who. Like Doctor Who releases overwhelmingly in the UK. Again, this is stuff you would not see just by looking at the raw data. And you can see that the darkest one is the most popular, so that's UK. And then there were a couple of US releases, and then there's more US and non-UK, basically non-UK releases after the series comes back. And you can see there was a period of time where there was no Doctor Who. Or no, at least no new Doctor Who. Let's go back to a regular query. Bum, 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 bum. And let's compare this with Star Trek. And I want to make this a different color. Will blue show up on this projector? Let's find out. Cool. How about Star Wars? Where is my thing going? Oh, live demo failure. Abort. One moment, please. Where are we, Doctor Who? It's almost like I've done this demo before. Doctor Who, best show ever. Let's just do those three. And let's go back to, I didn't want to do that. Live demos. Live demos are the worst. So Doctor Who, the whole point of this again is showing the shape of the data and that I am not, let's actually go back to 1900. Like we searched like hundreds of years of data, which is cool. You probably don't have hundreds of years of logs. No results. See, this is unfortunate. I may have crashed the server. This would be unfortunate. This is why it's good that we have lots of time. If I can't get this to work, I'll move on. It'd be cool if they weren't the same color. All right, let's try it one more time. Is it going to work? Yes. And we'll make you blue. Star Wars and Star Trek. Oh, you're correct. Doctor Who. Lots of colors going on here. And then I want to make this light. Will it work? Okay, so right off the bat, we're scanning 114 years of data, but you know the first release of any of these things was mid-1960s. So let's just zoom in. Much better. It's hard because there's a lot of noise, but you can see that there was kind of an empty block of time where there was no Star Trek. I mean, there was some, but not much. And then Doctor Who had a very similar space. What else were we looking at? Star Wars, very active when it was first released. Lots of nothing, and now they're exploding. Right? These are things that you wouldn't see. And again, we're not learning a complex syntax here. We're not learning how to write a config file to make a dashboard. We're just typing things in and poking around. Okay, so I think that's enough for the IMDb demo. The point, again, you're exploring your data. You're not typing complex queries. Like, what's this? Like, what's this big spike? Star Wars. And once you've zoomed in, maybe then it's useful to look at the wall of text that is the raw log data. But most of the time, it's not useful until you've narrowed it. You've really narrowed it down. So you can see Star Wars 6 was re-released pretty much in every country in April '97. Again, we're pretty far away from our systems at this point. So let's get back. Let's get back to Apache logs. So I loaded in, I think that was the next thing that I promised. Apache demo. We have about 20 minutes to do an Apache demo. If you have questions while I am doing this, or you see an anomaly, or see some kind of thing you wish to zoom in on, please shout out, raise your hand, let me know, and we can explore the data together. So I loaded in about 3 months of data. This little widget at the top, I'll make it light, lets you select the time range that the initial time range essentially that you're looking at. Let's do light so that the projector can show you. Excellent. So it's fairly fast. It's searching over, I don't know, 100 days of data. So right off the bat, you see there's two spikes. This graph is events over time. So every single event bucketed by 12 hours. So every single line is 12 hours. And maybe that's too many data points. Maybe that's just not, there's too much noise. So you could make it a day. And maybe that's a little bit easier. And you can already see patterns here, right? There seems to be this kind of bouncy curve that might relate to weekdays, and the low times are weekends. Let's look at this spike. one day is not useful for me anymore. So what we did was, we're going to zoom in and find out what this spike was. Figure out why it's an anomaly. Does that sound reasonable? Something happened a couple of days ago, and we're going to look at it. So March 13th, we zoomed in, and now we're looking at basically a 36-hour period, it looks like, from the 13th until the 14th around noon or 6 o'clock. And when we zoomed in, that spike became more apparent. And we can see that there's a definite shape here. So now I feel confident that we've found the window of time that represents the anomaly. And so what we're going to do is we're going to find out what that anomaly is. I'm going to try and show it all on one screen. So I shrank the little histogram graph, and I'm going to now ask for popular things. For example, let's look at common user agents, and I want a table of that. Because this is all web requests. So you can see some things that pop out to me initially, ignoring the counts, is that someone's chef is hitting my website. There's a bunch of Windows things. At the top, there's this Java thing that is overwhelmingly the majority of the data. And if you, again, we're exploring. We're not doing any weird syntaxy things. Is that if I were to theorize that this is the cause of the anomaly, using the magnifying glass or this, the circle with the slash through it, if I want to exclude it from my search results, I can just click it, and that shaped graph goes away, right? So that to me indicates that we found probably the cause of this data. So if I say include this user agent as the only thing we're searching for, the shape of the graph doesn't change, right? Does that make sense? And so now, what I want to do is I want to find what client this is. Like, is this a weird behaving server? If I were looking into a real production outage, maybe somebody's got a web spider or a web crawler that's going kind of crazy on my site and hurting performance. Now, let's figure out how to block it. So we will do top IP addresses. No, I want terms. Dun, 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 dun. So we can see those match, right? So let's get rid of this and see if there's any other. Let's get rid of the restriction that we're looking for, that guy, that specific user agent, and see if there's any other user agents that show up for just this anomalous IP address. So this IP address doing what I would say is weird things on my website. It had this spike, and then it kind of went away, right? It showed up for like an hour's worth of time, but it showed up with 3 different user agents, which is kind of weird, but mostly under one IP address. And now that we found the anomalous client behavior, I want to see well, let's see over time how is that client behaving. So we can get rid of the restriction that we're looking at, that when we zoomed in, these filters at the top, every time we zoom in, it adds a filter. And you can enable or disable a filter if you wish. And so in this one, I will toggle the zoomed in time thing. What we should see is I am disappointed. I have 2 filters with time. Who said that? 2 people recognized that. Thank you. OK, so we zoomed in. So now we are looking at just this, basically from the beginning of the year up until now. And this one particular client did its weird thing only in this one time span. So this to me says, like, if this were a weird behaving client, we could ignore it. We don't have to do anything because it's never come back. Does that make sense? So before getting in here, all we did was look at a spike and zoom in and try and move around and kind of reset our focus into how we're viewing the data. I haven't had to understand that it's Apache logs. I haven't had to understand the Apache log format. I just know that there are certain fields in the data You can actually search on them if you wish. But when you get if you look at the list of logs, you can get a breakdown. You can see that like there's the let's see if we can do a graph. I think that's another good example. Like the IP address is what fed in the GeoIP data. Bytes, we'll do bytes and let's do bytes and map. So bytes is good. I mentioned metrics. Every Apache request, every log in this example has a bytes value on it, and it's the bytes, basically the size of the transfer. And so maybe I want to graph the bytes. I don't want to graph the hit count. I want to graph the actual byte values themselves. So let's go back and start over. Let me check time real quick. Okay. All right, so let's look at past months of bandwidth. And this is, again, just hits over time. I don't want hits. I want bandwidth. So we'll call it bandwidth. And the value I want to graph is the total of the bytes field. If you're familiar with graphite, we're getting into graphite territory here. So now instead of plotting hits, we're plotting a sum of the bytes for every time period that we're graphing. And I don't see anything anomalous here, so let's try and do something a bit further back. Hopefully something shows up. Oh, there we go. See, again, you don't have to know what the data is to understand that there are weird patterns. So something happened. Like, I have a good idea with this, but like somebody was doing things, and then it stopped, and then they started again. And it was, whatever was stopped, it stopped for about a month. It's weird. So let's zoom in. Let's figure out what's going on. Let's do the same things we did before. I'm going to look at the user agent. And then from the user agent, I'll find probably the anomalous client, and then we can look at IP addresses. And this isn't just limited to Apache data. One of the questions I get frequently is, well, now that you've shown us this cool demo with Apache, well, I have Nginx. How can I do it? Well, the Logstash gives you the right tools to process any kind of log formats. If you're comfortable with using SSH and grep and sed and awk or not, those tools, like that's your tool belt. Right? And Logstash gives you a better tool belt, in my opinion. So let's find out what this weird thing is. So let's add, go back, terms. Again, looking at the user agent. Top user agent is chef. So if I want to see if I can blame this particular client for the shape of the graph, I want to exclude it, and the shape goes away, right? So that to me says we can zoom in on just this user agent. So, can everyone see in the back? I don't know how high this is. But it was gone for that month period, right? Completely gone. So we could do one of two things here. We could look at IP addresses, or we could look at, like, what is their chef client? Do you all know what chef is? Yeah, config management tool? Excellent, excellent. Let's look at requests. Dun, 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 dun. Singing helps the live demos. So top 5 requests. Only one file. Well, that's cool. So the site that these logs came from, what was previously the place that Logstash used to host its downloads. It no longer does, and that version is quite old, so someone's chef client is very frequently installing Logstash, I guess. What can we look at here? Let's zoom in, right? A lot of times your config management tools will run frequently, every 30 minutes, every so often. Let's look at a short time window. And so this is looking at basically a 20-minute period, and they've fetched it 17 times. That's weird. Over and over and over and over and over. Some people configure the config management strangely. Oh, what can we tell you about this? So my summary from this is, someone's chef client is behaving strangely. It seems like they're downloading it, installing it every couple of minutes, which is not what I would recommend. Maybe you install it once, per server at least. So maybe they have a bunch of servers downloading this file. Let's do that IP address thing again. And I'll show you a couple other tricks that you can do. Following the idea that exploration, it's not configuration. Both of these are what Kibana calls a terms panel. And terms panel just gives you the top somethings by field. There's different ways to visualize that data. You could have a list. You could have a bar chart. Bar chart's not super useful in this case because the data is so noisy. There's so many unique terms. But if you had something like, I'll show requests in a moment. But let's make this a here. So fairly even distribution, 6,000 requests. So let's zoom in on just one IP address. Fairly rhythmic. Seems like every 15 minutes, this one machine or one IP address is fetching an old Logstash release. Very strange. So let's do something more interesting and completely different. Let's do a breakdown of requests would be useful. So instead of looking at the agent, we're looking at response code as a pie chart. So overwhelmingly, 200 response codes are, if you have a healthy website, that means it's, things are good. But again, focusing on exploration, interactivity. If I want to look at all 404s, I can click on this orange segment that represents 404, and it zooms in on it. There's a big spike here. That's not cool. Maybe something bad happened, maybe it didn't. Does that all make sense? So we got here through using Logstash to parse the data, storing it in Elasticsearch, and visualizing it with Kibana. The primary interface you're going to be using is Kibana. That's what you're seeing here. As far as your operational concerns, my background is as a systems administrator. So we try and focus on having our tools and our releases easy to install. If it takes you more than 5 minutes, 10 minutes, something on a short order, if it takes longer than that to get started, to get to something like this, if you're trying Logstash for the first time or the whole stack for the first time, that's a bug. Something has gone wrong. So show up in the community. There's a mailing list. There's an IRC channel. If you need help, ask. There's no such thing as a bad question. And I don't want my least favorite thing is someone showing up after having banged their head on a keyboard for 2 hours trying to get this to work. Like that to me is an indication that we need to improve the documentation or improve the code. See if there's any other cool demos. If wireless is working, I will show the map because the map one is kind of cool. So let's look at. Yes.
Quick question. How do you work? Do you explore the graphing stuff in Kibana and then decide what is worse to graph in Graphite, or do you just use Kibana and use Graphite, or how do you?
So the question was about, where is the boundary of responsibility from Graphite to Kibana? My hope is that Kibana can do everything graphite can and better soon, but it is not now. The really nice property about Logstash is that you can use both systems. So you can have an output from Logstash go to Elasticsearch and Graphite at the same time. So if there are features in Graphite, of which there are many, that are really useful for drilling into metrics, to comparing lots of different data sets on the same visual, to applying mathematical functions to your data, to doing derivatives or integrals on your data sets. Graphite is very powerful at that type of thing. Kibana's not there yet. Like I showed graphing just the bytes. You can't, in Kibana yet, you can't say, show me bytes and latency on the same graph today. Graphite, you can do that, right? So again, with Logstash being sort of like a universal glue in terms of getting your log data into systems where you can find value in them, definitely use it. If you already have Graphite deployed, Logstash has a Graphite output, you can just, you'll be happy with it. You'll be very happy with it. Kibana isn't going to get there for probably a couple of months, maybe even longer. Graphite has a significant head start in terms of the mathematical and visualization functions for pure metrics. The thing where Graphite kind of falls over is getting from identifying the anomaly to the log itself. And that's why when I talk about Graphite possibly eclipsing the Graphite visual interface, is that you have both data sets in the same source. Graphite has this idea of, I think they call it events, but I don't think it's not very well formed yet, if it ever will be. I can show you, let me see if this one thing works. And then we can, aha, it worked. Yes. So don't let me forget about that, and I will talk about it just left my head, but so we are graphing the locations on planet Earth that our clients have showed up from, which is kind of cool. This is useful for your InfoSec team, knowing where attacks are coming from. It's useful for your marketing team, knowing where your customers are. I was going to show you something about why Graphite is superior in certain ways, and I can't remember what I was going to say.
Is it the type, the performance metrics?
Oh, yes. Singing always helps. So we have 6 minutes left. If you have questions, I will answer them while I am setting this up. So we have bandwidth. This would be a typical view. Let me make it look more like Graphite. Huh? Yes? Okay. Cool. Here we go. Graphite also excellent at exploration. I know a lot of people complain about the dashboarding capabilities of Graphite, but the Graph Explorer in Graphite is very powerful. Like, here's my list of metrics, throw them on a graph, make it this shape, do this transform on it. Very cool. Again, you're not learning a syntax for describing what the graph is looking like in a way. So I think this data set is poor, but what I would like to see, for example, is we had a graph that looked like this. That was latency in my slides, and like maybe you would like to, on this same graph, point out when certain things happened, like deploys. Like you had to deploy and then everything went to hell. Right? You could see that on a graph. If you had performance or health graphed at the same time as your deployments. With Graphite, and my data on this might be old, but they typically graph markers or events as a vertical line in Graphite. But with Kibana, you get this kind of exploratory system. Markers. And since we're only looking at pure Apache data, this is going to be a very crappy demo, but let's look at request response 404. I think this should work. Maybe? Well, there's one. That seems weird. Oh well. top 5 of 20. So the idea is that you could have one data set that is metric-oriented and one data set that's event-oriented, graphed on the same interface, and you can still explore. So what, again, this is a poor demo, but if I used what Kibana calls a marker on the histogram, and your markers could be deployment events, disk failures, those types of things that you would normally have in Graphite is like a vertical bar, but once you've turned it into a vertical bar, you don't know what it means. But because it's coming from Elasticsearch and we can visualize on it and we have the full event, you could see, I mean, this is again a poor example because it's bad data. But you would have markers that said, oh, a deploy happened here, a puppet ran here, a chef ran here, and then everything went bad. And then you can look at the puppet logs to say, well, what did you touch? And then from puppet, you can see the git or svn commit log and say, who touched what? Right? Again, we're traversing the system, we're starting with metrics, and we're looking at anomalies. We're finding a specific time frame that identifies the cause, and then we're going through the logs in terms of tracing things back. To me, that is the most powerful story I can tell about Kibana. And we have 3 minutes for additional questions. Wait. Can you export the diagrams? You can. I will answer that in 2 ways. You can crappily print to PDF, which is, you laugh, but that is one way to do it. You can also embed Kibana in an iframe. So if you have a specific view you wish to show on another dashboard, you can. So if you have a dashboarding system that lets you put Graphite widgets and other widgets on the same page, then this is the iframe way would be how you do that. And these things are all shareable. For like the IMDb example I showed you, Leonard talked about saved searches. Kibana doesn't have a saved search idea. It has saved dashboards. Those dashboards could have saved queries in them, but the idea is that saving a view, something that best represents a study of a given problem space that you can then share with people. And this is, again, going back to the IMDb data. And you don't have to use, you don't use a config file. You save it directly from the interface. And because it's searching against Elasticsearch, I mentioned Elasticsearch was great at a lot of things. Kibana's storage system is Elasticsearch. There's no backend or MySQL to set up. All the configuration for Kibana lives in Elasticsearch. So I can save this view as foobar, and it saves it. I can go to load, and there's foobar. Very cool.
Yeah, just a quick note on the link with Graphite. Maybe you know about Grafana?
Yes.
Yeah, so basically the author wrote a new dashboard for Graphite, and I think he based the code on Kibana.
Yep. Yes. So I haven't played too much with Grafana, but it gives you the same kind of feel as this interface does.
And how do you level the field when you come to a company and try not to scare off all the administrators? Because with Kibana you can measure them, and you have to have a culture that failure is acceptable. So
yes,
in companies I work for or used to work for, it's mostly okay. No one will know that the root cause was myself. So maybe in some companies, I think it will be hard to say, okay, now look at this, we will measure you all. And
yeah, so I think that fear is rational fear. On one side, we want to say like, oh, it will help you perform better, so there are less failures. But there's still that innate fear of failure. I mean, maybe the most obvious thing is to replace your use of grep, which hides possible failures from people you wish not to see those failures. You replace that with Logstash and Kibana and Elasticsearch or Graylog, but you don't expose that interface to other people outside the team, so that you still improve the efficiency and the speed at which you can debug problems through logs, but you're not necessarily you're not showing the entire company how many failures per minute you have. Right? I think that's legitimate, right? Like a lot of companies don't have outage pages. When Amazon has an AWS outage, they tend to be kind of hush about the scope or how many customers are affected, right? So there's going to be a boundary where it's not useful to show everyone exactly the shape of the failures that are going on, but I think you can put access controls in place to prevent that from happening, if that is your worry. And what I suspect will happen is it will be a two-step thing where you deploy something like Logstash and Kibana to solve your team's problems, and then you get good enough at solving problems quickly, and you say, well, look, we deployed this new open source tool, and our ability to debug things is much quicker now. And then that's a success. Right? And things fail all the time, right? My last Elasticsearch cluster I had a few jobs ago, we had 7 machines. They had, I think, total of 30 disks. I lost a disk a week, right? Which is really high. I don't know if our disks were really, really bad, but a disk failed a week, and that wasn't my fault. Like, it's not necessarily anyone's fault. I mean, there's just the hardware, it just fails.
Yeah, sure. But if you have teams that have 20-year-old guys and 50 or 55 or whatever years old guys, then the culture is very spread. So you have guys that are used to open source and openness, and you have guys that master grep for 20 years, and then now this young guy came in and look here, you click and woo, I did what you master in 20 years, and I do it better, and I do it Excel exportable. So
I think for that you just need to have good communication. I mean, the computers we're using today are much, well, I won't say they're better. They're faster. they're faster, and the capabilities are grander than we had 20 years ago. And so I hope we have tools like this that enable faster debugging. Right? 20 years ago, you may have had one server powering your entire business. Now you have 1,000. Right? It's a different scale. And so I think the fear of being replaced or fear of falling out of technological power is a very real fear, especially for older operations and technology folks. But that's part of why I want the openness of the Logstash community to be as open as it is. If you're not sure, like, ask a question. We're not going to make fun of you. We're going to make you feel comfortable and welcome. I think we are out of time. So, but if you guys have questions, I'm happy to chat during the break. We have a break now. Yes? No? Yes. Okay. And I also have, if you like the Logstash logo, I have stickers galore to hand out. Thank you.